acceleration due to gravity. So the three factors which affect centripetal force, always remember, you have to eliminate the proportionality symbol. Mass, length, acceleration, they are fundamental quantities. Hello students, this is SD sir, taking you all to the last session of discussion on units and measurements. And what is that we do in this session? Very important 5-mark questions where I teach you all how to derive physical equations using our method of dimensions. Now, the first example I have taken is using the method of dimensions, derive an expression for the period of oscillations. I am deriving an expression for the time period, exclusively time period of oscillations of a simple pendulum. Hope all of you have seen a simple pendulum in the high school lab. So here I derive an expression for the time period of oscillations of a simple pendulum, and that equation is of the standard form: T equals 2 pi root of L divided by G. The time period of oscillations of a simple pendulum is T equals 2 pi root of L divided by G, and using the method of dimensions, I will be deriving at the given equation. So this is the diagram of a simple pendulum. This is a vertical to which I have suspended a thread, and attached to this thread is the metallic bob. This is how your pendulum looks in general. Vertical. This is the thread that is suspended, and this is the metallic bob. Now, before deriving the expression, let us analyze the different factors on which the time period depends upon. The factors which may affect the period of oscillations of a simple pendulum. The first factor is the mass of the bob. Considering the factors which affect the period of oscillations. The first factor, mass of the bob. Second factor, length of the pendulum. See, length, the length of this thread from the vertical to the center of the bob. So this is giving me the length. The second factor is length of the pendulum. And the third factor is acceleration due to gravity. All these terms in depth in the next coming chapters. Type of acceleration. So the three quantities or the three factors which affect the period of oscillation is mass of the metallic bob, length of the pendulum, and acceleration due to gravity. Therefore, I write T, time period of oscillations, proportional to andre depends upon, this symbol is called the proportionality symbol. So time period is proportional to mass of the bob, length of the pendulum, acceleration due to gravity. Il ಮೂರು ಏನ್ statement wise ಅಲ್ಲಿ ಬರ್ದಿದ್ದೀನಿ, I've written it in expression here. T proportional to M, L, G. What is M? Yes, mass of the bob, sir. L, length of the pendulum. G, acceleration due to gravity. Now, you cannot solve a physical equation with a proportionality symbol. Always remember, you have to eliminate the proportionality symbol by introducing a constant. This cannot be solved because there is a proportionality symbol, and that proportionality symbol has to be eliminated, has to be taken out by introducing a constant. The constant I introduce here is K. So T proportional to M, L, G. This proportionality symbol is eliminated by using a constant K. Now, therefore now I write T is equal to K, M to the power X, L to the power Y, G to the power Z. Understand? Very clinical equation. T equals K. K was a constant. M to the power X, L to the power Y, G to the power Z, where X, Y, Z are arbitrary powers. My dear students, why did I use powers here? Why did I raise M to the power X, L to the power Y, G to the power Z? You can use any powers you want, random, arbitrary powers. But why powers? Because I told dimensions are nothing but powers to which fundamental quantities are raised. Mass, length, acceleration, they are fundamental quantities. In order to get their dimensions, I have raised to the power X, L to the power Y, G to the power Z. And I call this equation 1. Now, I write dimensions of both sides on equations 1. I have formulated an equation 1 and I write dimensions on both sides of equation 1. Left hand side time, dimension is t. K, what is K? Constant. What is its dimensions? Sir, in the previous session you told constants do not have dimensions. Dimensionless constant. M, mass, dimension is M. L, length, dimension is L. Small g, acceleration due to gravity. It has the dimensions of acceleration. What was that? LT to the power minus 2. Acceleration ನೆನಪು ಮಾಡ್ಕೊಳ್ಳಿ. LT minus 2 to the power Z. Or T equals K M to the power X L to the power Y. Here you have L to the power Z T to the power minus 2Z. I have simply split the terms in the bracket. L to the power Z, L to the power minus 2Z. Why have I done this? Because I've clearly told you all, or we know that if the base is the same, we can add the powers. There is a concept in indices which says if the base is the same, powers can be added. So you observe here, left hand side, dimensions of time, K constant, M to the power X. Now this is L, this is L. The base is the same. Power is added. Y plus Z T to the power minus 2Z. Now, I will equate the powers of X, Y, Z. Equating the power X. What is X indicating? Mass. M to the power X. X indicates mass. Do I have mass on the left hand side? No. So X is equal to 0. Why the power X is being 0? Because there is no mass on the left hand side. Length, power, Y plus Z. Do I have? No. Is there a length term on the left hand side? No. So Y plus Z is 0, or Y becomes equal to minus Z. T to the power minus 2Z. Is there a time on the right hand side? Yes. Power 1. So minus 2Z is equated to 1. Or Z becomes equal to minus half. Substituting Z is minus half, the value of Y is half. So X 0, Y half, Z minus half. So by comparison, I have arrived at the value of X, which is 0, Y, which is half, Z, which is minus half. Substituting the value of X, Y, Z in equation 1, T equals K, M to the power X, X is 0, L to the power Y, Y is half, G to the power Z, Z is minus half. Or T equals K, m to the power 0 is 1, L to the power half is root L, G to the power minus half minus, so root G comes to the denominator, or T equals K root of L divided by G. So my dear students, the very basic condition that mass of the bob affects oscillation is false. See, m to the power 0, it has no dimensions. So, mass has no participation in the period of oscillation. What is the value of this K? Dimensional analysis did not give me. It is from experiments. Please to understand. The value of constants always from experiments. And experiments gave the value of K as 2 pi. Therefore, we write T is 2 pi root L divided by G. And this is the required expression. So, from my method of dimensions, I have arrived at the time period of oscillations of a pendulum. And what was it? T equals 2 pi root of L divided by G. Next example. Using the same method of dimensions, I have to derive an expression for centripetal force. ಬಹುಶಃ ಕೇಳಿರ್ಬೋದು ಈ ಟರ್ಮ್ ಅನ್ನ, ಅಥವಾ ಈಗ ಜಸ್ಟ್ ಒಂದು ಫೋರ್ಸ್ ಅಂತ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. And that centripetal force is given by F equals mv square divided by r. So this is the expression I have to derive using the method of dimensions. So this centripetal force, some type of force, as I told, depends upon mass of the body. M is the mass of the body. V, velocity of motion, R, radius of the circular path. So the three factors which affect centripetal force: mass of the body, velocity of motion, radius of the circular path. So as we did in the previous example, now you will go on helping me. F proportional to m, mass of the body, it has to be V. So F proportional to m, mass of the body, velocity of motion, radius of the circular path. I have to eliminate proportionality symbol. What do I do? Introduce constant. Very good. So K is the constant. So F equals K, m to the power x, v to the power y, r to the power z. M to the power x, v to the power y, r to the power z. Again, x, y, z are constants. Now we write dimensions on both sides. Force mlt minus 2. K is a constant. M to the power x. V. What is V? Velocity. What is its dimensions? LT minus 1. R. Radius. I told anything with length should have the dimensions of L. Again, force. MLT minus 2. M to the power x, L to the power y, t to the power minus y, L to the power z. Again L to the power y, L to the power z. Same base, powers are added, equating which I get x is 0, y is 2, z is minus 1. So substituting, f is k, m to the power 1, v square, r to the power minus 1. So if you observe, we have a term called mass. You can see m, x, m, 1. So x is 1. So m to the power 1, v square, r minus 1, k, m to the power 1 is m, v square, r minus 1 goes to the denominator, 1 by r. Value of k from experiments, that is 1. So f equals mv square by r. So you see principally here how beautifully the method of dimensions is used to arrive at an equation. Now I give you all an assignment. The same way you're supposed to arrive at the equation for centripetal acceleration, A equals v square by r. With this, students, I complete the fundamental chapter, the most basic chapter, units and measurements. My next session, I come up with motion in one dimension. Go through the concepts of all what is taught. It will help you to understand the next session, the next topic better. Until then, have a nice time. Let's meet back. Thank you.